Hello, welcome to Pre-Calc, complex numbers and more quadratic equations. So the first objective is to simplify imaginary numbers. You need to write each expression in terms of I and simplify. So the square root of negative 100 is going to equal I times the square root of 100, which turns out to be 10I. Here where you have the negative square root of 1 and the negative square root of 12, pull the I out of each of the square roots. And then you get I, and then simplify the square root of 12, which gives you 2I square root of 3. And then you multiply your i's, which is I squared. And remember, I squared equals negative 1, and that's how you get negative 2 square root of 3. Same thing with division. Pull your i's out front, then they'll cancel each other out. 45 divided by 5 is the 9, so the square root of 9 is 3. Simplify and write the result in standard form, a plus bi. This is already in standard form, so if you divide by negative 3, you're going to get negative 3 plus 5i. Here you have negative 10 plus the square root of 125 over 5. You need to pull the 25 out, and the square root of 25 is 5, and that's how you get 5 square root of 5. And then you want to simplify. Negative 10 divided by 5 is negative 2, and positive 5 divided by 5 just leaves you with the square root of 5. Perform operations on complex numbers. Simplify the powers of I. Your book teaches you to find I to the 4th raised to a power. I wrote to find I squared raised to some power, and then remember that it's negative 1. It's up to you which way you do it. This is I squared is the way I learned. I to the 4th gives you positive 1, then you don't have to worry about whether it's positive or negative. So the way I did it, I squared equals negative 1, and I to the 3rd equals negative I. So I squared to the 16th, since it's an even power, your answer will be positive 1. With I to the 47th, you have to pull one I out so that you get an even number, which is divisible by 2. So you have I times I squared to the 23rd. Then since 23 is odd, your answer is negative 1. And if you multiply negative 1 times I, you get negative I. Here you have I squared to the 33rd. Since it's odd, your answer is just negative 1. You cannot work out a negative exponent for the I to the negative 27. So first you have to move it to the denominator of the fraction, which is 1 over I to the 27th. Then rewrite it as 1 over I times I squared to the 13th power. Then work out and you get 1 over negative I. Remember, you don't want I in the denominator, so multiply both the numerator and denominator by I. I squared divided by, I divided by negative I squared. I squared equals negative 1, and it's already negative, so that makes it a positive 1, and I divided by 1 equals 1. More operations on complex numbers. Here you're given 5 plus I over 4 minus I. You have to multiply by the conjugate, which is where the 4 plus I comes in. That's the conjugate of 4 minus I. If you do that to the denominator, you also have to do that to the numerator. Then you need to FOIL the top out. 4 times 5 is 20, and 4I plus 5I gives you the 9I, and I times I gives you the I squared. I squared is negative 1, so you add negative 1 to 20, and that's where the 19 plus 9I comes from. Remember, in the denominator, you do the multiplication, but you don't have to do the whole FOIL. It's just 4 times 4, which is 16, and negative I times I, which is negative I squared, which makes that a positive 1, added to 16 gives you the 17. Solve quadratic equations over the set of complex numbers. So you're going to use the same kind of properties we did in the last section to solve square roots, but now you're going to come up with i's in some of them and just regular answers in the other. So 8p squared plus 72 equals 0. If you're supposed to use the square root property, subtract the 72 over, divide by the 8, which is how you get p squared equals negative 9. P is going to equal the square root of negative 9 with the plus or minus. Remember, whenever you're taking the square root, you always have to have plus or minus. So the P is going to equal plus or minus 3i because the negative 1 comes out as the I. P squared minus 24p equals a negative 156. Either use the zero product property, completing the square, or quadratic formula. To do this, set the equation equal to 0. You get p squared minus 24p plus 156 equals 0. Since you can't factor, I would prefer complete the square. If you prefer the quadratic formula, use it. So if I'm going to complete the square, I move the 156 over and make it negative 156. 24 divided by 2 is 12, and 12 squared is 144. And negative 156 plus 144 is where the negative 12 came from. And then p minus 12, that quantity squared, is what the p squared minus 24p plus 144 factors into. And that's going to equal negative 12. Then you have to take the square root of both sides, which gives you p minus 12 equals plus or minus the square root of negative 12. So p is going to equal 12 plus or minus 2i square root of 3. And that's because 4 is a factor of 12. That comes out as 2, and the negative comes out as the I. Use the discriminant. The discriminant is the part that usually is under the radical. In the quadratic formula, it's b squared minus 4ac. You need to remember, if that's less than 0, then you have two non-real solutions. When b squared minus 4ac equals 0, you have one real solution. And when b squared minus 4ac is greater than 0, then you have two real solutions. So if I look at 5x squared minus 2x plus 4, I'm going to take negative 2, that quantity squared, minus 4 times 5 times 4. That gives me 4 minus 80, which is a negative 76. And since negative 76 is less than 0, you will have two non-real solutions. Solve equations in quadratic form. You need to make an appropriate substitution and solve the equation. Here, if I can get rid of the 3x minus 7, I would have a variable squared with a variable here, and then I'm used to factoring that. So in this case, I'm going to let u equal 3x minus 7. So I get u squared minus 6u minus 16 equals 0. Then factor, and you get u minus 8 times u minus 2 equals 0. So either u minus 8 equals 0 or u minus 2 equals 0. Then substitute back in the 3x minus 7 for the x. So when you put the 3x minus 7 back in for the, I should have said u, you get 3x minus 7 minus 8 equals 0, or 3x minus 7 minus 2 equals 0. So 3x is going to equal 15, or 3x is going to equal 9. So x equals 5 or x equals 3. In this next one, I want to leave the square here, but I want to get rid of the 3 in the denominator, which leads to this exponent of 1/3 being what I need to get rid of. So in this case, I'm going to let u equal d to the 1/3. So I have 3u squared minus u minus 4. And then that factors into 3u minus 4 and u plus 1. That way we get negative 4u here and positive 3u here to get my negative in the middle. So set each part equal to 0 and then substitute back in. So 3d to the 1/3 minus 4 equals 0. or d to the 1/3 plus 1 equals 0. Divide by the 3 here, and then raise it to the power of 3. And on this one, you're just going to have to raise it to the power of 3. So 4/3 to the power of 3 is down here, and that's going to equal 64/27. And negative 1 cubed is going to be negative 1. Okay, that's it for example problems today. Hope this helps with your homework.